Hello everyone, welcome to QPGX Academy. This is our lecture number 3 of simple harmonic oscillators. Okay. Uh, in the previous lectures, we have already discussed the what is the commutations relations. What are the commutations relations between lowering operator, raising operators, and number operators, as well as we also find out the energy eigenvalues. Okay. We also find out the energy eigenvalues of harmonic oscillator, nth state harmonic oscillators, right? Mm, so so in today's class, we are discuss a very important points. What is the points? Points are actually when an lowering operators acting on nth state. Okay. uh, when an lowering operators acting on nth state, then what happened? Okay. And a raising operators acting on nth state, then what happens? Okay, we deal it in very details, right? But in the competitive exam purpose, for in competitive exam purpose, the formula, the final result is very important. Okay. And how can I get the final result? It's not important, but it's important for semester exam purpose. But the final result is important for your competitive exam purpose. Just be careful, right? Okay. So okay, right. Okay. So we are already know, right? We are already know, when a cap acting on nth state, then it decrease the states by unit, and we have a eigenvalue c minus. Let us assume that this is equation number 1. Actually, we find out what is the value of c minus. Okay. Similarly, when an raising operators acting on nth state, then it increase the state plus 1, and I get the eigenvalue is c plus. This is equation number 2. Okay. So our task is actually what is the value of the eigenvalue. Actually, it's a coefficient c minus and c plus. Okay. So now we can find out the coefficient of c minus and c plus. This is our main goal actually. Okay. So right, so let's start the process. Let us take the Hermitian conjugate, the Hermitian conjugate of equations 1. Hermitian conjugate. So if we take Hermitian's conjugate of equations 1, it means a cap n cap dagger, okay, c minus dagger n minus 1 dagger. Okay. So it gives the value as like that, as if we know in kit, if we take Hermitian conjugate, it gives you bra, right? So brass in a cap dagger, it's equals to c minus assume the coefficient is reals, right? Real coefficient. Okay. I assume it's a real, not real coefficient. It's like it's complex conjugate. We already know it's a complex conjugate. Okay. Similarly, n minus 1 brass, right? So this is equation number 3. Now take a scaled multiplications between equations 1 and equation 3. Now take scalar multiplications of equations 1 and equation 3. Then what do you get actually? In brush, a cap dagger, a in cat equals to C minus complex conjugate, C minus n minus 1 brush, n minus 1 grid. Okay, so we know this part gives you the plus 1 value, right? This part gives you plus 1 value. You already know this is actually. Okay, so finally we get in brush cap dagger a cap in cat equals to C minus complex conjugate, C minus into 1. Okay, so in brass cap dagger a cap in cat is equals to C minus complex conjugate, C minus, and it is equals to C minus mod square, right? It is equals to C minus mod square. You already know the methods actually. Now we already know if a cap acting on n cat, a cap acting on n cat, it's have a eigenvalue n and its eigenstate will be n. Already we know, right? In the previous class we already discussed about that. Actually let us assume this and then we assume this and we derive all the mathematical calculations. Please remember this. So this is equals to n cap dagger n equals to C minus mod square. So it is equals to n is constant, so n a cap dagger n equals to C minus mod square. Okay, right? So a cap dagger, when a cap dagger acting on n cat, it also gives you the eigenvalue m, right? So it is equals to, no, I think we do perform a very I think we are performing a wrong step. Okay, don't worry, sorry, it's my mistake, sorry. Okay, okay, it is my mistakes. yeah, this is equals to n a cap dagger a cap incat, right? As we know, cap dagger a is equals to n cap. It means number operators, right? It's a number operator. So any number operators acting on n state, it gives you eigenvalue n and n kits. Just remember this, okay? So finally we get n into n kit equals to c minus mod square. So we get n into n kit to n brass into n cat, so c minus mod square. So we get c minus mod square equals to n, so c minus equals to root ends, so c minus equals to root ends. So we get the value c minus equals to root ends. So c minus equals to root ends is very important. Okay, for C plus we performing the same process. Let us take, this is equation number 4, this is equation number 4. Again we take Hermitian conjugate of equations 2. So we get a cap dagger in cat equals to c plus cap dagger, sorry, n plus 1 dagger. Okay, so it's gives you n brass a cap equals to c plus complex conjugate n plus 1 brass, and this is equals to equation number 5. Now take complex scalar multiplications between equations 5 and equations 2. Okay, so we get n brush a cap dagger n kit equals to c plus complex conjugate c plus n plus brass n plus kit. So we get value n a cap dagger n equals to c plus complex conjugate c plus. So finally we get a cap dagger n cat equals to c plus mod square. So now what is the value of this? This is very important, please remember this value. Okay, please remember this value. A cap into a cap dagger, when acting on n we get n plus 1 into n cat. Okay, just remember. And for the previous case, a cap dagger a cap, when acting on n we get n into n cat. Just these two values are very important, please remember. Okay, just remember. We prove that also. We prove it also, right? Don't worry. Don't worry, okay? Okay, okay. So we get n plus 1 into n plus n get. So c plus mod square. So finally we get c plus equals to root n plus 1, root over n plus 1s. So we get the coefficient c plus and c minus. So a cap dagger when acting on n cat, we get n root under n plus 1 cat, and when a lowering operators acting on n cat, then we get root n minus 1 cat, and when a cap dagger a cap acting on n cat, then we get n cat n, and a cap into a cap dagger acting on n cat, we get n plus 1 into n cat. So please remember all the value in details. It's very important, okay? It is very important for your exam purpose, right? It's very important. So finally we got the result. These fours are very important for your exam, for IIT JAM, JEST, TIFR, okay, COCT, etc. For all the exam, this part is very important, and for semester, the derivations part is also important. Okay. Next we go to the matrix elements of lowering operator, raising operators, and number operators. Take a heading: matrix element for a cap lowering operator, a cap dagger raising operators, and number operators. Okay, matrix elements of a cap dagger, a cap dagger, a cap. Please remember these three things. So m brass a cap into n. M or n are two different state actually. Two different state. What we get actually? What we get? As you know, when a cap acting on nth state, then we get root n minus 1, right? So it is equals to root n m plus n minus 1 cat. Okay, and it is equals to root n delta m minus n minus 1s. Delta m n minus 1. This is the matrix elements. This is the matrix elements for a cap, and also we find out the a cap daggers. Okay, so now m a cap dagger n. What is the matrix elements? This is equals to m. We know when a cap dagger acting on n cat, it is equals to root under n plus 1 cat. So this is equals to n plus root under n plus 1 m n plus 1. So this is equals to root under n plus 1 delta Kronecker delta m n plus 1. Kronecker delta m n plus 1. And for m a cap dagger a cap is the number operators. For number operators in acting on n state, we already know what we get actually. Okay. This is equals to n cat, and this we get in n cat. So this is equals to n m plus n cat. So this is equals to n delta mn, n into delta mn. So these three are the matrix elements. These three are the matrix elements for lowering operator, raising operators, and number operators. Okay. Okay. Let's find out. Let's find out very important. Let's find out the very important result. What are the result? If we know the lower state, then by raising operator, we can find the higher state. Exactly. We are already know when raising operators acting on n state, then the state is increased by 1 unit, right? So if we know the lower state, then by raising operators we can find out the higher state. So we prove that. Okay, so we prove that. It's a very important statement. Please remember this statement. Okay, so raising operators when acting on ground state, then what we get? 0 plus 1, so 1 into ket 1s, right? Similarly, raising operators when acting on state 1, then we get 1 plus 1, so this is equals to root 2, right? Similarly, from these equations, we get K2 is equals to a cap dagger K1 by root 2, right? So if we know the lower state, then we easily find out the, if we know this is the known state, if we know this state, then we easily find out the higher order state by applying raising operators. Okay, just deal this concept. Similarly, a cap dagger acting on 2, if you're trying to find out the value of state of 3, we're trying to find out the state 3, right? And we know the state 2, right? If we know the state 2, that is known, and we find out the state 3. How can I find out? We just apply raising operators on state 2, then we get root under 2 plus 1, that is equals to root 3 ket 3. So ket 3 is equals to a cap dagger ket 2 upon root 3, right? For similarly, for nth state, what can I get? For nth state, if you're trying to find out the nth state, cap dagger n minus 1, we get n minus 1 plus 1, n minus 1 plus 1 ket, so root n, so ket n is equals to a cap dagger n minus 1 ket to root n's. Okay, so this is a very important result. Please remember. So if we know the lower state and then apply lower raising operator on this state, we find out the state of higher order, right? This is the approach. Just remember this. This is important. Okay, this is important. Just keep in mind this result. Okay, next concept. Next we go the next concept. Another important concept. If we know the higher state, then by lowering operators, we can find lower state. Okay, if we know higher state, then you can find out the lower state, right? You can easily find out the lower state. So okay, let's do it. Try to develop this concept. So a cap acting on ket 1. So what can I get? This is equals to root 1 into 1 minus 1. So 1 0 state. Okay, now lowering operator acting on state 2, so it is equals to root 2 into 2 minus 1, so that is equals to root 2 ket 1. So ket 1 equals to a cap acting on ket 2 upon root 2. But if we try to calculate, this is the approach, right? A cat 3 equals to root 3 minus 1 ket, so it's ket root 3 ket 2. Okay, so k2 equals to a cap root ket 3 upon root 3. Okay, so there is no problems, but in the examination, in the competitive exams, they give you a very difficult problems, right? In JST examinations, in one time, in the JST examinations, they ask a very interesting questions. What type of questions they ask? If we know the nth order state, what is the questions? If we know the nth order state, then how can I calculate ground state? It means we know nth state. From nth state, we're trying to calculate ground dot state. This is known, and this is we calculate. How this can be possible? This is very important questions. Okay. Don't worry. Right. Let's perform the step-by-step approach, and finally we get important conclusions. And using these conclusions, we easily calculate any kind of higher state to ground state. Any order of higher state to ground state, we are easily calculate. Actually, it's represent how to calculate ground state from any order of excited state, any order. Fourth order excited state to ground state. Okay. Fifth order excited state to ground state. 10th order excited state to ground state. We can easily calculate. This is the questions. Okay. This is the questions. So we apply here step-by-step process. A cap lowering operators acting on state 1, then we get 0 ket. So next a cap acting on 2, then we get root 2 ket 1. Okay, so ket 1 equals to a cap ket 2 upon root 2, right? So ket 0 equals to a cap ket 1. Just substitute the value of ket 1, a cap ket 2 upon root 2. So we get a cap square ket 2 upon root 2. Okay. So this is equals to a cap square equals to root 2 factorial k2. We can easily write it. Okay, so from this is the step actually we'll find out from k2 to k0. Next we find out k3 to k0. How can I find out? Same process we do. A cap k1 k0, a cap k2 k1. So this is equals to k1 equals to a cap root 2 1 root 2. Next a cap acting on k3 is equals to root 3 k2. So k2 is equals to a cap k3 is equals to root 3. So k1 is equals to a cap by root 2 a cap by root 3 to k3. So it is equals to a cap square root 2 into 3 k3. So now 0 ket equals to a cap ket1. So it is equals to a cap square root 2 into 3 ket3. Okay, so finally get a cap root 3 upon 3 into 2 into 1 to get 3. So finally we get a cap whole cube upon root over 3 factorial 3 cap, right? So this is the approach from root 3 ket to 0 ket. So for in generals nth ket 2 we are trying to calculate ground state is equals to ground state a cap whole to the power n upon n factorial n ket. This is a very important result. It's very important actually. This is asked in GST examinations. Just in TFR examination. It's very important. This result is very important. Okay, so finally we get a very important note. Notes H by the action of a cap lowering operators and raising operator, we can calculate the eigenfunction of one-dimensional linear harmonic oscillator. Okay, so next task is we are trying to find out the ground state eigenfunction of harmonic oscillator. Ground state eigenfunction of harmonic oscillator. Let us take a heading. Ground state eigenfunction of harmonic oscillator. It's very, very important for your exam. Okay, ground state eigenfunctions of harmonic oscillator. So let us take a statement. If we if we apply lowering operators on ground state, then we get 0. It's true. Okay, because ground state is the lowest state. If we applying lowering operator, then what can I get? राइट, इससे कम तो हम लोग स्टेट नहीं मिल सकते ना हम लोगों को. इट्स ऑब्वियस, राइट? So if we apply lowering operator on ground state, then we get definitely 0. Then we get 0, right? So it means a cap acting on 0, we get 0. Okay, so we have, this is equation number 1. We have lowering operator a cap equals to m omega upon 2h cut x cap plus I upon 2h cut m omega p cap, right? So this is equals to m omega 2h cut x cap plus I upon 2h cut I omega minus IH cut delta x. We apply here momentum operators, of one-dimensional momentum operators. So this is a px. Okay. So now from equations 1, we get m omega upon 2h cut this cap plus I minus IH cut del del x upon 2h cut m omega zero cut is equals to 0. Okay, so let us resume 0 cut is equals to ground state. So it's written here like psi 0x. Okay, so m omega 2h cut x cap plus h cat del del x upon 2h cut m omega psi 0 of x equals to 0. 0 cat, it's written here, it's a ground state like psi 0x. Okay, so it is equals to h cut del psi 0x del x upon 2h cut m omega plus m omega upon 2h cut x cap psi 0x equals to 0. Okay, so del psi 0x on del x equals to minus m omega upon h cut. Just simplify this. Okay, it's very easy, you do it, I know you do it. Psi x psi cap equals to psi 0x equals to 0. Okay, now integrating both integrating both side. This is very easy integrations. Psi 0x equals to integrations m omega upon h cut x cap del del x plus ln c. Okay, so this is equals to ln psi 0x minus m omega upon h cat x square 2 plus ln c. So this is equals to ln psi 0x on c equals to minus m omega x square on 2h cut. Okay, so psi 0x equals to c e to the power minus m omega x square upon 2h cut m omega x square upon 2h cut. So right, m omega x square upon 2h cut. So this is the ground state wave functions, and this is the normalized constant. C is the normalized constant. Okay, next we try to find out the value of the C normalized constant. Then we get the ultimate expressions of ground state wave functions of harmonic oscillators. Okay, applying normalization constant. Normalization constant, sorry, normalization conditions, not normalization constant. Apply normalization condition. What is the conditions? Conditions is minus infinity to plus infinity. We already discussed here. For harmonic oscillators, the turning points are actually minus infinity to plus infinity. So actually particle moving in minus infinity to plus infinity. So by default we take integrations minus infinity to plus infinity. So there is no doubt. I think and no one have any kinds of doubt why you take the integration limit minus infinity to plus infinity. Okay, psi 0 complex conjugate psi 0x dx equals to 1. So this is equals to mod c square minus infinity to plus infinity minus m omega x square upon 2h cut into minus m omega x square upon 2h cut dx equals to 1. Okay, this is equals to mod c square minus infinity to plus infinity e to the power minus m omega x square upon h cut dx equals to 1. This is the even functions. Okay, 2 this is the even functions. So 2 mod c square 0 to infinity to the power minus mx square upon h cut dx equals to 1. Okay, so 2 mod c square to the power minus x square you perform it by using gamma functions. Use gamma function and finally you got the result, right? Finally you get the result. What is the ultimate form of wave functions, of ground state wave functions? Okay, I think there is no problems. I think there is no problems. I know how to deal the ground state, how to know, you know the process, how to deal gamma functions. It is a very easy tricks for you, right? It is very easy tricks for you. So everyone do it and send me the solutions of these equations. What is the ground state wave functions of harmonic oscillator? Just do the one or two steps and send me the solutions. Okay, send me the solutions. What is the actual form of the ground state wave functions? Okay, you just find out the solutions of, find out the value of c. This is your tux, and then find out the what is the actual form of ground state wave function. This too is your homework. Okay, use the gamma function rules here, gamma function rules, and find out the value. Okay, let's do it. I think you do this. Okay, so this is the form of, so finally we got the ground state wave functions. Of one-dimensional harmonic oscillators. This is a very important result. Okay, this is a very important result. Next class, I think I will take a class in Saturday. Then I must upload this video also, and I will upload at least two videos in a week. I think it's a benefit for your preparations. Actually, I have a lot of work because I am a researcher. I am actually try to help you to save my after my work. Okay, after finish my work, then I find out 1 hours for recording videos. okay, for recording videos. So I think it's help you. So if anyone uh, uh, if anyone have any kinds of doubt, please message my WhatsApp group. I definitely give the solutions in my in my own times when I actually free. Okay, actually, already know I'm a researcher, so I have no sufficient enough. I have not enough time to communicate with you in a consecutive way, but I try my best to connect with all the students and guide to you. Okay. So if I delay to respond any of the student for their questions, please don't mind, because I have lot of pressure only. I'm working in my lab from morning 9 p.m. to uh, evening 9 p.m. So many thought actually going on in my mind, and so that's why not that's why I am not able to upload videos in consecutive way, right? So break I take break in my free times. I will I will record those videos, and definitely upload my YouTube channels. Okay, so don't worry. I, I definitely I will upload two videos, at least two videos of more than 1 hours. Okay, more than 1 hours, and I will also upload the PDF file in my description box. So it's a very easy to access that. It is very easy to access that PDF. Already you all are very smart how to know it. Okay, so this is today my class is actually end of here. So thank you again. Thank you for watching this video, and please like my videos and subscribe the channel. uh, if you got any kinds of if you got any kind of benefit from this channel, so please do it. uh, and don't mind if I delay any of the way to upload the videos, but you trust me, I definitely upload you, right? I definitely find my time and upload these videos. Okay, okay, thank you.